Well, hello again, everyone. We have the Slumber model SM-21A vacuum tube voltmeter, and this is the same meter as the Heath kit IM-13. And what we're going to do is freshen this meter up, clean it up a little bit, and give this thing away. Now the meter's not really too bad. There is a mark here. I'm hoping I can get most of this cleaned off. The face, I polished it with just polished. I have not went and took a polishing kit and sanded it down and polished it up to try to get some scratches out of it. Although I did polish it, and I mean, you can completely see through the meter with no problem. But I mean, they don't really show up on camera that good. But there is some scratches in the meter face that will need a little attention if somebody wants to detail it on further. I may take it off and go ahead and get some 2000 grit paper and sand it down, and then try to buff it back out. I don't want to damage it. Anyway, we'll see how that goes. I think the front of it will clean up very nicely without any problems. Again, one thing that I didn't like was someone cut this square hole in the back, but there's nothing we can do about that. At least it does have a proper line cord on it, as you can see. Now, I do want to go ahead and warn you, whoever gets these meters, and if anybody that uses a meter like this, when you install a 3-wire cord on this meter and you plug your probes into it, make sure that when you connect the ground clip, you're connecting it to ground. Do not connect this to a live circuit. And the reason being is that this is completely earth grounded. So if you're going to check some main voltages, just don't stick these up there and test the main voltage. Make sure this is on the common or neutral ground side, and let your probe touch the hot. And the reason for that, again, this is earth right to the chassis of this. So if you don't have this and you connect this up and it's plugged into the wall, it's going to trip a breaker and it's going to arc on you. So be very careful with these type of meters that has a earth ground on it. That's just a caution I want to let you know on it. But let's take a peek on the inside, see how it looks. I'll get the camera a little closer. Okay, there we go. You can see the inside of this unit is very clean. Looks real nice. The wafer switches look real good. There's no black tarnish or anything on them, so they look good. They'll be easy to clean up. We have a few adjustment potentiometers over here we'll need to clean up, and I guess the first thing we're going to do is go ahead and get these bad caps out of here. Well, I'm not going to say bad, but these old caps. You can see we got one here, there's one down here, so that's 2. There's another one here, so 0.5 microfarad, 0.05 microfarad at 400 volts. And then we got this 1600 volt, say 0.047, that we may have to replace also. So I'm going to go ahead and grab the capacitors out of the drawer, and we'll go ahead and work on getting those replaced. So I got 3 of the 4 caps here that we're going to replace. And I had ordered a, say, 0.047 at 1600 volts for this cap, and I did not get it. I'm going to have to go back in and check my invoicing and see why it didn't come. It might have not been in stock. I do have a 0.05 at 1600 volts, and it's a brown dip capacitor, but I'll check it just to see, and if it checks okay, we'll probably just leave that one in there. It's mostly the electrolytic and wax style caps that we really need to get out of here. And you know, just see how that goes, see how the circuit functions with that in it. Maybe later on, if I can find one before the giveaway, I'll go ahead and replace it. If not, I'll see if I can't locate one and then send it to whoever wins this in the giveaway. So I'm going to go ahead and pull out these old caps and go ahead and replace those 3, and then we'll check some resistors and stuff and get these 2 tubes checked. Again, I don't think the looking at it, it doesn't look like the battery holder has ever had a battery installed in it, just from the sight of no corrosion at all in here. So that's very good, so we don't have to worry about replacing any of this. Or I was going to look at building the battery saver circuit and put in it, but as good shape as this is in, I don't see no need to. Alright, I got our electrolytic here installed, and now I want to go ahead and replace the 2 0.05s at 400 volts, and I'm replacing them with 0.05s at 600 volts. And I've already marked the ground side, and the reason being that, well, I'll leave a link down below to Paul over at Mr. Carlson's Lab, where he'll explain that to you. But you want to make sure you have your ground on the outer side of the foil on these, not on the connected to the inside. So now we'll go ahead and get both of these installed. Okay, we're here on the old workbench, and we have a 12 AU7, and you know, this is a dual tube, so there'll be 2 tests on it. So we'll get a look here. 12 AU7, first function is on 4, 6.3 with a load of 62. So we're on 4, on 6.3. We'll dial this up to 62. Up 1, down 9. And we'll plug our tube in. Let it warm up just a minute. Okay, we should have a short test on 4, 5, and 8. It shouldn't short on nothing else. It's 4, it's 5, 6, 7, 8, shorts, 9. And we'll check the tube and see what it reads. It's about 78. This tube tester does read a little low. And we want to check the other one. We'll drop 1, bring up 8. And short test on 3, 4, and 5. I read that wrong. It's supposed to be 6. I was wondering why it was shorting on everything. Alright, 3, 4, and 5. That's 3. That's 4. That's 5. No short on the rest. And it's about 78%. So if you notice, tube checks a little lower. Both elements are reading the same, which the tube is balanced out pretty good. And I much rather have a tube reading a lower percentage but balanced out on both elements than I would a tube reading 90 on one element and 100 on the other. Our next little tube, this is a little tube, it's a 6AL5. So let's set the meter up for 6AL5, and on the first element, A circuit goes to 1, 6.3. Let me drop this down to 40, and we'll go up 2, down 3. So we'll plug this in. Short test on 1 and 4. Short test looks good. Make sure the line's 0 and test. And we're about 82%. So now we want to drop 2 and pick up 7. She's short on 4 and 5 only. Short test looks good. And about 82.5%. So that one there looks good too. So our tube's in great shape. And I don't know if I ever showed this meter or not, or even talked about it. This is a Knight. It's a KG600B tube tester. I only use it for reference only, especially if we're just matching tubes up and checking for shorts. You know, the real tube test is inside the equipment. Okay, tubes installed. To clean the tube pins, I got down here with a Q-tip and deoxit and cleaned all these wafer switches. You can see how much cleaner they are now. They weren't that dirty to start with, so all that looks good. I went ahead and I tested out the resistors. I went ahead and went through some of these precision resistors and tested them out, and they're all fine. So all that looks good. So now the only thing is to power the unit up and calibrate it. So as always, the first thing you want to do with the meter unplugged, turned off, is calibrate the meter. Make sure it's directly on 0. Right, so make sure you, when you calibrate these meters, you do it after the meter has warmed up for a while. Our next test, I'm going to be using my set of probes, and we're going to calibrate the DC scale. And the way we do this is plug it in, we'll put it on DC plus, 1.5 volts. Make sure the meter's zeroed. And here you'll see a little red dot right there on the meter. And we want to set this by using this DC calibrate pot to 1.5 volts. And you can see it's way over. Let me set the meter up so we can see it a little bit better. They can be a little touchy sometimes. There we go. Okay, we need to set the ohms range and make sure that's working right. The manual tells us to go to DC ohms. I have a fresh battery clipped in, and we want to be on RX 1K. And what we need to do is set the ohms adjust to the infinity mark. We'll make sure our AC ohms switch is in the right position, and we'll short the two together, and the meter fills exactly to 0. So there's nothing we have to worry about on the ohm scale. That is working perfect. Now next calibration will be the balance between AC, DC minus and DC plus. And what that means is when we switch to DC, and we'll zero out the meter. When we go to DC minus and AC, the meter shouldn't move. Make sure I'm zeroed out real good. AC to DC, nothing at all. Looks real good. We need to set the AC range, and we can see that we're running at about 121.8.9 volts today. So we're going to take our meter, we're going to set it to the AC range, 150 volt scale. Now if you remember before, I told you that this was already earth, so you'd only have to use your ground clip. And we had about just a little better than 120 volts. So I'm going to just leave that right there, because you know, whoever gets it is going to have to calibrate it themselves also. Yes, a little better than 120 volts. So our AC scale looks fine too. So there's only two more things to do. As you can see, the meter is working perfect. I see no problems with it at all. It's a good working meter. The only thing I need to do is clean it up. I'll do that off camera. But we do have to make a probe. Now, again, you know, the only probe I had is the one that I have with mine up here. So I've actually got to make two probes, because I've been swapping this probe from this one to the Heath kit on the other bench. So I am going to have to make two probes. So we're going to go ahead and see if we can't make a probe and get it built for this meter. So if we look here in our manual at our probe, you can see the only thing in there is a switch and a 1 meg ohm resistor. Now when you go to the DC range, this 1 meg ohm resistor is in series with the lead. When you go to AC and ohms, it just bypasses the resistor. And then our ground lead is common to the chassis. And that's all it takes to get a meter working, a probe working for this. So that should be a very simple probe to build. I'm just going to look around the shop, see what we can come up with, and we see can't we put this probe together. I will also be sending this manual along with the meter, so whoever gets it will also get an assembly manual and calibration manual with the meter. Now you can see I got a few things here on the bench. I have a piece of PVC type. I have this tip right here that screws out of this piece, alligator clip, a switch, 1 meg ohm resistor, and some test lead. So what I want to do is take this and get this mounted inside this tube, and then we'll drill a hole and this switch will run up in there, and we'll have a hole here and it'll come out, and it'll have two mounting screws on it. So I just need to find a way to epoxy this in the center, and then everything can be slid in from this end, and the wire coming off the switch will slide through the hole in this, and then you just solder it on and screw it back on. That's what I have in mind. I thought about making this a compression fitting, so when the wire is inside and it just screws on into it, touches the wire. But I'm not sure how I'm going to do that yet, so we'll just have to look at it and see. We might just end up drilling a small hole through here and let it come out the side, so that wire can come out here and then be locked on. We'll look at it though and see. Shouldn't be too hard. Alright, just to show you where we at, we have the hole cut out for the switch. I have the probe tip installed. This just unscrews. You see there's a screw right here that holds this spacer, which is another piece of this PVC pipe cut, and then the green piece is support is slid into it. So all this can be removed, or services have to. The tip just screws right in, and what we'll do is just fold the wire over onto this and solder it right to the jack. This way when you screw it along, you ain't twisting the wire around and breaking it off. Then if you have to take the tip off, just unsolder it, straighten it out, screw it out. Next thing to do is go ahead and get the wiring done, and get the resistor mounted to the switch, and get all that slid in. Then we'll put a plug in the back and one piece of test lead coming out, and I'll clean up this end here also. Okay, I got a switch network made up. We have our resistor here. This is the wire that's going to go out to the probe, and this will be the wire going to the hot lead going back, and you switch between DC and AC. And when you switch to DC, what it does, it puts this 1 mega ohm resistor in series with the tip. So all we got to do is just get this slid in, connect our center lead to it, and we should be good to go. And I got to make an end cap for it. Okay guys, meter's all together, probe is built, DC, AC, little switch right here. You can just click it back and forth with your thumbnail, no problem. Good silicone wiring, no cheap wiring on it. I used the best wiring that I had for it, but everything's ready to go. I do have some cosmetic things I'll do over the next week. Alright, for the giveaway, rules for the giveaway: you must be subscribed. I need to be able to verify that you're subscribed. If you want the meter, just put in your comment, all I want is, I want the meter. That has to be in your comments below. Now regular folks that just want the comments, fine, but if you specifically want the meter in this giveaway, I want to see I want the meter in the comments below. And we'll run this over 2 weeks, and at the end of 2 weeks I'll pull the comments and usernames, and I'll put it in the hat, and we'll draw it and see how it goes. So with that, I hope you enjoyed the video. Like I say, this meter was in excellent condition to start with, as far as, you know, mechanically and electrically. It does have a few cosmetic flaws I'm going to work on, but other than that, I think it's going to be a good meter. And if you want it, let me know. Leave your comments down below. We'll see you in the next video. So, you know, I'm not getting into a lot of theory of how this meter works. In fact, if you want to see some theory on how it works, I'll link down below a video that Paulo at Mr. Carlson's Lab did on a unit that's very similar to this. I think his was a 9th, but it's basically the same circuit. But what I do want to tell you is, you remember when we was checking the tubes, we were finding that the dual triodes, both elements were reading about the same, and that is what you're looking for when you're rebuilding one of these vacuum tube voltmeters. It's like the 12AU7 here. You see you have two elements in the tube. And if you look at one side, pin 7 grid is has a fixed bias on it. So your voltage, you know, is going, if you testing DC voltage, it's going to come in through your probe, go through your 1 meg ohm resistor, and it's going to go through your function switch, and then down to your range switch, where it'll go through the correct precision resistor for that range that you have it in. But it winds back up, all the way back up here to pin 2 of the 12AU7 through this R12 resistor, which is a 3.3 meg. And as it, you know, receives it, the voltage is picked off, and as it receives, it causes one side of it to draw current, and that's what deflects the meter. If you see right here, the meter is actually, here it is in the middle of the two cathodes. So one side is fixed, the other side goes to the probe, and that causes the meter to deflect the correct voltage or meter reading. And so, you know, always go in and make sure that the tube elements are somewhere around the same percentage, and that's what good a tube tester like that is for. And as far as really checking the tube to see how good it is, and you know, in the circuit is always the best way. If you don't get your tubes balanced out right, you'll find that your reading's going to be off. And you could compensate by going in and changing some components here, like this 10 meg resistor, but you don't want to do that. Just find the correct tube to put back in that has somewhere, you know, very close to the same matching on each element.